Hi everyone, good day. My name is Bonifacio P. Mercari Jr. and I am here with my group mates, of course, Mr. John Rick Lapas and Mr. Janelle Martinez. We are here today to discuss the fundamental concept of quantitative analysis approach. But before that, let's talk about what is quantitative analysis. Quantitative analysis is based on describing and interpreting objects and statistically and with numbers. Quantitative analysis aims to interpret the data collected for the phenomenon through numeric variables and statistics. Quantitative analysis includes computational and statistical method of analysis. So, quantitative analysis is a technique that uses mathematical and statistical modeling, measurement, and research to understand behavior. Quantitative analysts represent a given reality in terms of numerical value, and also quantitative analysis is applied to measurement, performance evaluation of a financial instrument, and predicting real-world events such as changes in country's gross domestic product. So, quantitative analysis predicts outcome using values and statistics. And also quantitative analysis collect data through measurements. And lastly, quantitative analysis reports data in statistical values. So here are some fundamentals of quantitative analysis. Do you know that QA views from three perspectives? First is its characteristics. Second, its process, and of course, its tools. But of course, let's talk about first the major characteristics of quantitative analysis. So the major characteristics are the following. First, a primary focus on managerial decision making, the application or employment of scientific approach. Problem and decision are viewed from a systematic perspective. And of course, the use of methods and knowledge from several disciplines, application of formal mathematical model, and lastly, human factors. So these are the major characteristics of quantitative analysis. So quantitative analysis process and or approach. So the fundamental quantitative analysis approach consists of defining the problem, develop a model, acquiring input data, develop a solution, testing the solution, model validation and sensitivity analysis, and of course, its implementation. So do you know that there are 5 fundamental concepts of quantitative analysis? If yes, then that's great to know. But if no, that's perfectly okay because for today's discussion, we're gonna talk about the 5 fundamental concepts of quantitative analysis. So the 5 that I mentioned a while ago are the main factors that affect the quality of your findings. So let's talk about reliability. So what is reliability? Reliability is a measure of consistency of a test, and also it is the degree to which an assessment tool produces stable and consistent results. In other words, reliability is a measure of the consistency of a metric or method. every metric or method we used, including things like methods for uncovering usability problem in an interface, an expert judgment must be assessed for reliability. In fact, before you can establish validity, you need to establish reliability first. Here are the most common ways of measuring reliability for any empirical method or metric. First, inter-rater reliability. Second, test-retest reliability. Third, parallel forms reliability. And of course, lastly, internal consistency reliability. Enter rater reliability. The first one. The extent to which raters or observers respond the same way to a given phenomenon is one measure of reliability. Where there's judgment, there's disagreement. How to measure? To measure enter-rater reliability, different research conduct the same measurement or observation on the sample. Then you calculate correlation between their different sets of results. If all the research gives similar ratings, the test has high inter-rater reliability. The second one, test retest reliability. Customers respond consistently to identical experiences. So again, how to measure it? So to measure test retest reliability, you conduct the same test on the same group of people at two different points in time. Then you calculate the correlation between the two sets of results. So we have this improving parallel forms reliability. So this is to ensure that all questions or test items are based on the same theory and formulated to measure the same thing. So another one, we have this internal consistency reliability. So the degree to which test items measures the same construct. So how to measure it? So two common methods are used to measure internal consistency. So first is the average inter-item correlation. So no, for a set of measurement designed to assess the same construct, you calculate the correlation between the result of all possible pairs of items and then calculate the average. So the next one is the split half reliability. You randomly split a set of measures into two sets after testing the entire set on the respondents. You calculate the correlation between the two sets of responses. So improving internal consistency. Take care when devising questions or measures. Those intended to reflect the same concept should be based on the same theory and carefully formulated. So in this slide, as you can see, I've already provide a summary in order for you guys to easily understand, comprehend, and also remember the reliability. So here are a few things to keep in mind about measuring reliability. So first is reliability is consistency of measure or method over time. Second is reliability is necessary but not sufficient for establishing a method or metric as valid. So the third one is there isn't a single measure of reliability. Instead, there are four common measures of consistent responses. So, another one is you want to use as many measure of reliability as you can. Although in most cases, one is sufficient to understand and understand that the reliability of your measurement system. So the last one is even if you can collect reliability data, be aware of the ways in which low reliability may affect the validity of your measured and ultimately the veracity of your decisions. So again, I am Bonifacio P. Mercado Jr., your first reporter, and also the next part will be discussed by Mr. John Lapas. So thank you.
The validity of a research study refers to how well the results among the study participants represent true findings among similar individuals outside the study. This concept of validity applies to all types of clinical studies, including those about prevalence, associations, interventions, and diagnosis. Statistical significance. In research, statistical significance is a measure of the probability of the null hypothesis being true compared to the acceptable level of uncertainty regarding the true answer. Experimental validity refers to the manner in which variables that influence both the result of the research and the generalizability to the population at large. It is broken down into two groups. First is internal validity, and second, external validity. There are eight major threats to internal validity. First, history refers to any event outside of the research study that can alter or affect subject performance. Maturation. Maturation refers to the natural psychological or physiological changes that take place as we age. Testing. People tend to perform better at any activity the more they are exposed to the activity. Statistical regression. It refers to the tendency for subjects who score very high or very low to score more toward the mean on subsequent testing. Instrumentation. If the measurement device used in your staff changes during the course of the study, changes of scores may be related to the instrument rather than the independent variable. Selection. Selection refers to the manner in which subjects are selected to participate in a study and the manner in which they assign groups. Experimental bias. We engage in research in order to learn something or to support a belief or theory. Therefore, we as a researcher may be award the result we want. Morality. Morality or subject dropout is always a concern to researchers. They can drastically affect the results when the morality or mortality quality is different between groups. External validity. How well we can extrapolate our findings to the experience of real users in a real world situations. Four of these threats are discussed below and summarized. Correlational research. A correlational research design investigates relationships between two variables or more. without the researcher controlling or manipulating any of them. It's a non experimental type of quantitative research.